Alrighty, we are in Chapter 2, Section 2, called Solve Two-Step Equations. This is for Math 8. So as always, I'm just going to go over this screen really quick. So this is the front screen for doing your homework on Alex this year. You will also see a due date here. Oops, didn't mean to move my screen. You will also see a due date on the beginning here. I don't see a due date on mine because this is the teacher preview. It doesn't give me a due date, but you will see one here for you. You always have unlimited retakes, so you can come in here and take this as many times as you would like until you get the grade that you're happy with, or 100%. This particular assignment has 6 questions in it, and the grading policy is always best score, so no matter how many attempts you come in and do or try out, you always have the best one. So if your very first attempt was your best score, that is your score. Hopefully as you go in and do it, you kind of increase it each time. Partial credit just means that if you answer one of 6 questions, you get credit for that one question. It doesn't mean partial credit within questions. Sometimes there's multiple answers within there. You don't get partial credit within a question. You either have to answer the whole question or not at all. But if you answer the question, then you get the points for that one. All right, and then this little reminder at the bottom, once you start your homework, you must finish it. What that means is in the bottom right corner, there's a Submit Assignment button. And no matter what, when you are leaving the assignment, you click Submit Assignment, even if you've only answered one of 6 questions, because that way it will not lock you out of every other assignment. If you just leave the screen, or like say hit the X button, and close it, it's going to make you come back to this assignment. It's going to lock everything else out. Nothing else will be clickable. So always click that Submit button. Number 1, it tells us the score you currently have on it. And number 2, it allows you to move freely to another assignment if, say, you want to work on topics for a little bit or something like that. All right, so I'm going to click Start. Within here, there's always these 3 buttons. Sometimes there's more, but within here, there's always at least these 3 buttons. This is explanation. It will explain this exact problem to you. Super cool feature, because now if you're confused on maybe just this problem, not necessarily the entire problem type, but you don't like the format of this one, I can see the answer to it. I can see the solution, right? But it's going to take the attempt away. It's going to give me the answer to this question. So I'm not going to be able to come back and then, answer that with what they just gave me. I'm going to have to come in on another attempt and try this question again. I can also click on explanation, which will literally open up an explanation page, so I can scroll down, read through the explanation, say, oh, okay, I get it. That's what they want me to do, and then close this one. If I want to see another explanation, I just click here again. It'll give me a new one. So it's not the same one. It'll give me a new one each time. And then you can also message your teacher there, which will attach this exact question to your message so they know kind of exactly where to focus the help there. All right, let's go ahead and start these 6 questions here. So we're going to solve with 2-step equations. Hopefully that's kind of an obvious name. 2-step means we're going to have to take 2 steps to solve this guy. What I like to do is write down PEMDAS. And PEMDAS is for simplification. Remember this. So we go across the top from left to right, and this is for simplifying. So simplify. From left to right, we do parentheses, exponents, then we multiply or divide, then we add or subtract from left to right. Once we're completely simplified, then we can actually still use PEMDAS. You just have to remember it's a little bit different. We're going to go backwards to solve, but one of the main things we have to ask is, what are we adding or subtracting on the same side as a variable? What are we multiplying or dividing on the same side as the variable? So it's just a little question. You really shouldn't have to go past multiply or divide, with the exception of maybe if you had like x squared in your equation. Right now, we shouldn't have things like that in 8th grade. I don't think they're going to give us that anytime soon, so we don't need to necessarily worry about that part of it. So we shouldn't have to go past multiply or divide. So I just like this little graphic because it reminds us simplify from left to right, and then you can even do this little thing. You're flipping around and going kind of backwards, and you can still use that same method to help you solve. Okay, so first, let's make sure we're simplified. So we have 65 equals 1 minus 8u. So we have no parentheses. We can check that off. I have no exponents. Again, I can check that off. Multiply or divide. I do have multiplication here, but I can't actually multiply 8 and u because remember, u is a placeholder for a number. Instead of it just being like a blank space, like, I wonder what that is, we gave it a name. We said, okay, you will be u right now, just so that you're holding my place there. And then I do have addition and subtraction here. So remember, close. This negative belongs to the 8, all right? So I'm actually adding 1 here. It's a positive 1. So be careful about that. Don't say, oh, you're subtracting. This is negative 8. We do read it as 1 minus 8u, but minus and negative are actually interchangeable. They mean exactly the same thing. So just be careful with when you're identifying what's happening. So I'm simplified. So now I can flip over, and I'm even going to change my color so you know I'm in the solve stage now. So we look at what is being added or subtracted on the same side as the variable. We're always looking to get that variable by itself. So again, we're not subtracting 8 on this side. This is a negative 8 that's being multiplied by u. I'm adding 1 on the same side as the variable. So I want to do the opposite operation because 1 minus 1 cancels. But I also have to do it to the other side of the equal sign. So remember, there's a left and a right here, right? If we do our little line, we have a left side and we have a right side. So that's what we mean when we say you have to do it to both sides there. All right, so 65 minus 1 is 64 equals 1 minus 1 cancels, which is exactly what we want to happen. When you're moving something from left to right, this is what you should find happening. You should have 1 positive, 1 negative of the exact same number when you're adding and subtracting. When you're going to the next stage here, so we bring down negative 8u, now I'm going to move over and look for what's being multiplied or divided by the variable. You can say on the same side as the variable, but it's by the variable. It should be literally right next to it or right underneath it. So right here, we're multiplying by negative 8. So I want to do the opposite. I'm going to divide by negative 8 on both sides. 64 divided by negative 8 gives me negative 8. So negative 8 times negative 8 goes back to 64. I can kind of test that out and make sure. Equals any number divided, any number divided by itself is 1. Negative 8 divided by negative 8 is 1. It doesn't matter what the number is there. If I had a decimal divided by a decimal, it would be 1 as long as those decimals were exactly the same. If I had a million divided by a million, it would still be 1. Any number divided by itself is 1. That includes variables too. If we had u divided by u, well, they're the same number even though we don't know what they are. They're just placeholders for the exact same number. All right. So we know u has to be negative 8. And so what we do is we go on this list and we say, okay, so u has to be 8. Well, that means it can't be these other ones. So you're only going to select one of the 4 solutions. All right, you're not going to select more than one. So the other method to complete this problem, which I know the explanation, I believe, is kind of going more in this direction. So I'll pull this up. Is what it's doing is it's showing you to create a table and actually plug in each solution and see, do you get a false at the end? Are the numbers incorrect? Negative 16 does not equal negative 44. Or do you get a true statement? Negative 44 does equal negative 44. So this is another method that they're having you solve. So if you already know PEMDAS, if you remember this, then you can by all means go through this. If this is a little advanced, we can start by doing it in a different way. So I'm going to go back just to give myself room. So we have 65 equals 1 minus 8u. So what we're going to do for each one, so here's my first one, minus 8. And my first number that they want me to try is 2. And what we're doing is we're plugging it in. And we want to see, does this side, when I plug in 2, does that equal 65? I'm just testing it out. That's the whole purpose here. So I'm going to go 65 equals 1 minus 8 times 2 is 16. 65 equals 1 minus 16 is negative 15. Nope, that's not true. Not true. So then I would click no for 2. And I would go through and do the same thing for each one. 8 times negative 3. Oops, I had that in red before. I'm going to keep my pattern going here. Negative 3. So you can see I'm changing. It's the same exact equation, but now I'm going to use the second number they asked me to use. I'm just going to plug that in and see. do I in fact get 65 when I plug this in? So now negative 8 times negative 3, I get positive 24. So now I get 65 equals 25 when I add 1 and 24. Well, that's still not true. We're getting closer. Not true. So now if I go down to my next one, 65 equals 1 minus 8 times negative 8. Boop, boop. Now I have 65 equals 1. Negative 8 times negative 8 gets us positive 64. 65 equals 1 plus 64 is 65. Ooh, that one is true. So this would be my yes, just like we've already found. And then you'd want to make sure you test that last one as well to make sure. You should find only one solution right now. We have a single variable. There's only one number that you could plug in to make this true. So you shouldn't find more than one yes. You can find all no's. I'm going to say that very clearly. I have found some of these problems where they are all no's. That does not mean you're wrong. You may want to go back and check your math, but you can always check it. And if it's not the correct answer, you can go back and check your math and try again. But you should not find more than one yes. Okay? All right. Go to the next one. I'm going to erase these guys. Boop, boop, boop. Okay. So in this one, they don't give me the numbers to plug in. That was only on that first one. So here, we do officially need to use PEMDAS. Oh, darn it. I had already erased PEMDAS. I'm going to say I already had that written there. Dang it. PEMDAS. All right. So remember, we're simplifying. Simplify if you need to. And then solve. And I know I flipped the colors here, but that's okay. Solve going this way. Okay. So solve. But you should be able to stop right there. You should not have to go to parentheses and exponents in this case because that means you have not simplified your problem. So now we have 58 equals 4w plus 14. So we want to go through and simplify first. Do I have parentheses? Nope, no parentheses. So check. Do I have exponents? Nope, I don't have those. Check. Multiplication or division. I do have 4 times w, but remember, w is a placeholder. I can't really multiply those until I know what w is. So it just stays there. And then addition or subtraction. I do have addition here, but I can't actually add it to my variable yet because it's being multiplied. I need to wait until I figure what that is. All right, so we have simplified. We are going to go through and solve now. So first step, what is being added or subtracted? We're looking for addition or subtraction on the same side as the variable. So I'm adding 14 there because plus 14, add 14 means the same thing. So in order to undo this, I need to do the opposite. Plus 14 minus 14. Those will cancel. And I'm going to do the same side to the left here. So now I'm going to subtract and I get 4 and I get 4. And that equals 4w comes down. 14 minus 14 cancels. If this doesn't completely cancel out, you have not done the opposite operation correctly. So always make sure it's 1 positive and 1 negative. That's exactly how we cancel out completely. I had 14, I took 14 away. And it doesn't matter if you had negative 14 and you added 14 to it. You can do it the opposite way there, as long as 1 is positive and 1 is negative. All right, so now we're looking for multiplication or division on the same side as the variable or being done to the variable. So I'm multiplying by 4 here. The opposite of multiplication is division. 4 divided by 4 is going to cancel, which is exactly what we're looking for it to do. So on this left side, we have 4 divided by 4 is 1. 4 divided by 4 is 1, so that's a kind of a quick division there. So that's 11. Again, 4 divided by 4 is 1. So now we have 1w, but I don't have to write 1w. I can just write w. So w equals 11. This is the same thing either way. 11 equals w, w equals 11. That's a symmetrical property. We can flip-flop those around. It's not going to hurt anything. It's not going to change the answer because they always are going to have the variable equals the number. They're never going to let you type in 11 equals w. So just be aware you can switch that around. Yes, it looks different. I flipped it, but it means exactly the same thing. Okay, let's try another guy here. All right, so we are going to write this down first. Minus v equals 227. Okay, so it looks like no parentheses, no exponents. I do not have it really multiplication or division, although technically this is a -1 being multiplied by the v. Okay, and we'll come back to that when we're solving. And I do have this 130. Remember, it's not being subtracted. Negative belongs to the v. The 130 is being added. It's a positive 130. Okay. All right, so we can't simplify anymore, so we're going to switch over to our different color here, and we're going to do red for solving. So addition or subtraction on the same side as the variable, we already talked about that. It's the 130 that's being added. So again, be careful. This throws students off almost every time, and they think, oh, there's subtraction happening. You're not wrong necessarily. You are subtracting v, but what we're looking for is the number that's being added or subtracted. So again, just kind of be careful. Always look for the sign that's in front of the number when you're looking to cancel things out. So positive 130, negative 130, those cancel out. And we bring down negative e. Make sure you bring down the negative with it. It belongs to the v. And then we have 227. We're going to subtract 130 from it. So we could 7. We'd have to borrow here, right? So this would end up being 9. And it's a positive 97 because it was 227 minus 130. So the only thing we don't want to do here is I don't want to know what negative v is. So we can't just leave it like this. So remember, this was a -1 being multiplied by the v. So just like I would with any other number, I'm looking for multiplication or division that's being done to the variable. Well, I'm multiplying by -1, so I'm going to divide by -1 on both sides. -1 divided by -1 cancels out to 1. Any number divided by itself cancels out to 1. So v equals 97 divided by -1 simply just makes it -97. Okay? So we get -97. Check. Yay. All right, we're going to move to the next one here. And again, hopefully we're really starting to understand this two-step process. We're going to find what's being added or subtracted and do the opposite. That's our first step. And then we're going to multiply or divide by what's being, we're going to do the opposite of what's being multiplied or divided by the variable. That's our second step. So really this part of me asking you to simplify, this would really be a third step if they were asking us to simplify. So this is just me going through and making sure we understand it's part of the process, but I don't believe any of these are going to need simplification. Maybe once we get to number 6 here. We'll see. Okay. So again, if we go through our PEMDAS, I don't have parentheses. I don't have exponents. I do have multiplication division, but I can't do anything with this multiplication. I do have a subtraction here, but I can't necessarily do anything to simplify it yet. So I can't actually subtract it from 5 because 5 is being multiplied. So I can flip over to my solving color here for red, and I'm going to look what's being added or subtracted on the same side as the variable. 2 is being subtracted. Remember, -2 is the same thing as -2. So it's +2 on both sides because opposites. I have a negative, I have a positive. They will cancel. This is another one that does throw students off when the negative is on top and the positive is on the bottom. It doesn't really change anything at all. It is still a negative and a positive, and they're the exact same number. So they still cancel out just the same as they would if it were +2 on top and -2 on the bottom. So now I have -27 plus 2. These are opposites. I had -27 and I added 2 to that. So that means I'm going to actually subtract them. And since I have more negatives than positives, it's going to be -25. So another thing to watch out for integer addition, if you have a negative and a positive, you're actually going to subtract them, and the bigger number tells you what your sign is going to be. So 27 is definitely more than 2, so I need to make that negative. All right, last step, what's being multiplied or divided by the variable? We are multiplying by 5 here, right? So I'm going to divide both sides by 5. 5 divided by 5 cancels down to 1. Any number divided by itself is 1. -25 divided by 5 is -5. Make sure you bring the negative down because it's a negative divided by a positive. So we need that negative in order to make this true. Check. Okay, continue. 2 more of these guys. Ooh, we're getting into some fractions here. I keep erasing a little bit more of my solve every time I do that. All right. So we have 7, or v divided by 7 plus 5.1 equals negative 6.1. So we're getting into some fractions and some decimals. So we're throwing both of them at you now. So on this one, again, we want to go through our PEMDAS. No parentheses, no exponents, multiplication and division. Well, I do have division, but I can't do anything about it. It's a variable being divided by a number. And I do have addition, but again, I can't necessarily simplify that. I have to leave it alone until I know what this v is. All right, so now we're going to flip over and we're going to start to solve addition or subtraction that's on the same side as my variable here. So I'm adding 5.1 on the same side. So I'm going to subtract 5.1. V divided by 7 just drops down here. Any number minus itself, so positive 5.1, negative 5.1, those cancel out to 0. And now I have negative 6.1 minus 5.1. They're both negative. I spent $6.10 because we could put a 0 on the end. And then I went to another store and I spent another $5.10. So if I spent both, I'm going to combine to know how much I spent total. I like using money because for whatever reason it seems to make a little more sense for everybody. So we want to add these. So it's going to be 2.11. Sorry, 11.2. I said it backwards as I was writing it down. And then I put the negative on there because I'm combining the negatives together. Just like if it was 6.1 plus 5.1, we don't tend to question that one as much. We just add them together. They're positive. So if they're both negative, we do the same thing. We just keep the negative. All right, now we look at what's being added or multiplied or divided by the variable. Sorry, talking funny over here. So I'm dividing by 7, and that's what this fraction means. So I'm going to multiply both sides by 7, like that. 7 divided by 7, any number divided by itself, cancels down to 1. And now we want to go through, and you can do this multiplication off to the side if you need to. 2. And you can go times, and I'm going to ignore the negative just for a minute. I know my answer is going to be negative because it's a negative times a positive. So I'm just going to ignore it for a second when I'm doing this. So 2 times 2 is 4, 2 times 1 is 2, 2 times 1 is 2, and now I have one decimal place, so I need to take that and move it back 1. So it's just kind of a practice in multiplying decimals there. So it's going to be negative 22.4. That's what V needs to be. Negative 22.4. Check. Uh-oh. I went wrong somewhere. Let's see. What did I do? Oh, why was I multiplying by 2? Silly me. I was supposed to be multiplying by 7. I'm just losing my crazy mind here. That was silly. It should have been 11.2. 11 times 7. I don't know why I wrote a 2 down there. I'm not even thinking about it there. 7 times 2 is 14. 7 times 1 is 7, plus 1 is 8. 7 times 1 is 7. So again, we have one decimal place here, so I would have to move it back. So I would have 78. And we need to make sure it's negative, because again, that negative doesn't change. It's still negative times a positive. So my answer will be negative. I was just ignoring it for a second in my calculation because it's a little easier to think about it without it. Check. All right. Silly me, multiplying by the wrong numbers. Does that happen? Do we make mistakes? Of course. Everybody makes mistakes. All right. Okay, so I'm going to get rid of this. We're going to look at some scenarios here, and we just need to think about what kind of story can we tell about these numbers. All right. So in this case, I have 19 of something. All right, that's what this means. 19 of something. Excuse me. Excuse me again. So this is what the 19 part means. And then I'm taking away 38. So we want to hear some kind of take away type words. I'm withdrawing, I'm subtracting, I'm removing, something along those lines. And Together, the total will be 475. So this guy is our total. So if we can remember, we just want to kind of break this down. It's depending on your problem. Of course, you're not going to have these same numbers, but you should have something similar to this where you're going to have a number, a coefficient times a variable. So that's, in my case, it's 19, so it's 19 of something. I just need to look for that in the story. And then I'm going to be taking 38 away from that. A lot of the time they're talking about money here because it's a little easier, again, to compare this stuff to money. And my total will end up being 475. So we just have to break that down and understand this is what the pieces mean. So I'm going to point down here like this. Okay. So let's read our first scenario. A rental car company charges X dollars per day. This month, there is also a discount of $19 off the entire rental fee. Okay, so let's think about that. It's $19 per day. So if I multiplied 19 by the number of, or the X by the number of days, or the charge per day, then that might work. But they didn't. That's not what they're saying here. Now they're switching it up and saying it has a discount of $19. Discount is one of those minus words. That tells me I get to take that off. I get to subtract that away. Well, that's not what's happening with the 19 in our equation here. 19 is being multiplied by X. So this should need to be more like a daily fee if we were looking at this situation. And in this case, I want to uncheck that. They're saying they rented the car for 38 days. So in their situation, they'd be multiplying 38 by the X, not 19. So that one doesn't work. Doesn't match up with what we're talking about. Next one says a rental car company charges X dollars per day. Okay, so X is still days. That's my something, the days. This month, there is also a discount of $38. Ooh, that works. Taking off $38, right? That's our discount. Jane rented the car for 19 days. Oh, okay, so this is definitely starting to work. This is the number of days. This is my something, and she did it for 19 days. And she paid a total of $475 after the discount, which means after we took the $38 off. Perfect. That totally works for our scenario. And this, you could have one answer, you could have 4 answers, or you could have no answers and none at the bottom. So just make sure you read through each one. Don't just find the first one and go, okay, I'm done, and move forward. A rental car company charges $38 per day. Well, per tells me that there should be some kind of multiplication happening with 38. So right away, from that very first sentence, I know this one doesn't work. Because we're not multiplying 38 by anything, we're subtracting 38. A rental car company charges $19 per day. So, okay, 19 per day. We are doing a per with this one. We're multiplying 19 by something. And in this case, that would mean that X would be the days. So this month, there's also a discount of 38 off the entire rental fee. Oh, discount means I get to take that off. That works. Jane rented a car for X days. Okay, so they confirmed X is the number of days. She paid a total of $475 after the discount. All right, perfect. So I have my $19 per day. I have my discount of $38, and I have my total of $475. So this guy also works. And then I can click check. Please, for each lesson, click for clicking the next button. I did. Oh, got it. I didn't realize there was another question down there. Ha ha ha. Okay. So we're going to take into account this scenario now. Now we don't have 19 of something. Now we have 7 of something. And we're adding 42. So that's going to be an increase word we're looking for. And then the total will be 98. So it's the same idea as this guy. But now we have 7x plus 42 equals 98. So now 98 is our total that we're looking for. We're adding 42, and we have 7 of something. Sorry, I know that's getting kind of sloppy there, but so now these are our pieces that we're looking for. 7, and this is not 2. That would be a backwards 2 anyway, but that's of. All right, so let's read through our scenarios. Ryan sold shirts at a festival. He sold 7 shirts for X dollars each. Ooh, okay. Each is a multiplication word. And he sold 7 shirts for X dollars each. So 7 would be the number of shirts, and X is the fee that we don't know how much he sold them for. His expenses were $42. Well, expenses is one of those words, hopefully that kind of triggers our understanding of, we're going to take that away. If it's costing it, or it's an expense, it costs us money. So we're not subtracting 42 in this scenario, we're adding 42. So that doesn't work. That one sentence means it doesn't work. He left with $98 after the expenses. That does still work in here because it's 98 for the total. But because of this one sentence here, the first scenario doesn't work. Ryan sold shirts and hats at a festival. He sold 7 shirts and made X dollars for each shirt. Okay, that still works. If he sold 7 shirts and he made X dollars for each shirt, if we multiply those two together, we'll know how much he made on the shirts. And then he also made $42 from selling hats. Ooh, that would be a plus 42. That's another $42. We just don't have to multiply it. He's not telling us how many hats and how much they were. He's just giving us a total there. And if we put those two together, we'll know how much he made for the day, right? Or at the festival, which was $98. So all of these pieces fit. He sold 7 shirts for X dollars. Here's a plus 42 and a total of 98. Ryan sold shirts and hats at a festival. He sold X shirts and made $7 for each shirt. Okay, so this is the same scenario, but now it's flipping it around. Now we don't know how many shirts he sold, but we know he's selling them for $7 a piece. But that still works for the multiplication. And he also made $42 from selling hats. Okay, same thing. That's a plus 42. That's an additional $42 he's making. And the total is $98. So this guy also works. Even though we flip-flopped it, it was 7 shirts for X dollars. The second scenario was X shirts for $7 each. So we're still using the same two numbers and we're still multiplying. We're just defining them slightly different there. Ryan sold shirts at a festival. He sold X shirts for $7 each. Okay, that still works. X shirts for $7, right? We don't know how many shirts, but we know they were $7 each. His expenses were $42. Oop, just like that first one, expenses is a minus word. We're not subtracting 42, we're adding 42. So I know that one's not going to work either. All right, so now let's go ahead and click check. Yay! All right, so that was section 2, and I will see you in section 3.